In this video, we'll be studying the concept of refraction. Refraction refers to the behavior of light when light goes from one substance to another, and as it goes from one substance to another, you can see that it's bending over here. Earlier we studied reflection, which was when light hits a surface and then bounces off. So it doesn't go through, but it bounces off. So here you can see a better diagram of refraction. We have a boundary between two substances, air and glass. A substance that light travels in is called a medium. So air is a medium, glass is a medium, honey is a medium, diamond's a medium. And so here you can see that the light is going from air to glass, and as it goes from air to glass, there's a bit of a bending. It doesn't continue on this path over here. Instead it goes here and then changes its path a little bit, and that's a bending. And that's called refraction. So this here is an incident ray, and this is a refracted ray, and we're going to learn more about that terminology soon. So a medium is a substance in which light travels. Now, the reason that this change in direction is happening, or this bending of light is happening, this refraction is happening, is because the light changes speed from one medium to another. So light doesn't travel at the same speed everywhere. As light goes from air to glass, the light ray bends because the light's traveling at different speed within those two media. So that's the concept of refraction, and we're going to focus on that in this presentation here. This here is an example of refraction happening and some effects it might have on organisms. So you can see over here that we have a fish, and this is a fish's prey. And so what this fish does is it actually squirts water out at the insect up here. Now what's interesting is that when the fish is underwater, it doesn't actually see the insect here where it is. It actually sees the insect over here. So it appears here. There's a virtual image that appears here because the light rays from the insect go at the water. When they enter the water, they will bend because the light speed changes, so that's refraction, and goes into the fish's eye here. And then the brain does not realize that bending is happening, almost like when the reflection happens in a mirror, and then makes an image appear here. But the interesting thing is, if you watch this video, you'll see that this fish is able to calculate for that and actually aims the water at the insect over here, even though it sees it over here. So this fish is basically doing optics. And you can watch that video for more details over here. So we're going to talk about something called the index of refraction. The first thing you need to understand is that the speed of light depends on what medium it's in. So the light doesn't always travel at the same speed. In space, which is a vacuum, meaning an area where there's very few particles, light will travel at its fastest, which is 300 million meters per second. M/s means meters per second. You can also write it in scientific notation, 3.0 times 10 to the power of 8 meters per second. If you need a refresher on scientific notation, you should access your tutorial notes on scientific notation to review that idea. So please make sure you are comfortable with scientific notation, as you're going to be using it quite a bit in this lesson and going forward. It's also a very important skill for grade 11 and grade 12 courses in the sciences. So the index of refraction, here's our formula for it. N is equal to C over V. N represents the index of refraction. C represents the speed of light in space, which is 3.0 times 10 to the power of 8, so 300 million meters per second, the fastest light can travel. And V represents the speed of light in some other substance. So it could be speed of light in water, speed of light in air, speed of light in diamond, speed of light in glass. And so what the index of refraction is basically a number that tells you how slow light travels in a substance compared to space. So for example, if I have an index of refraction of 2 in a substance, what that means that in that substance, light travels 2 times slower compared to space. Or if I have an index of refraction of 1.5, what that means is that in that substance, light travels 1.5 times slower compared to space. So the index of refraction is essentially a measure of how slow light moves in one medium compared to space. And so if you have the speed of light in space, which you always do, it's always this constant here, and the speed of light in the substance, then you can figure out the index of refraction. This diagram here shows you how the speed of light is calculated in different substances. So you have light sources here, and then you have a tube here with a substance that you're interested in. So here we have empty space, here we have air, here we have water, here we have glass, here we have diamond, and here we basically have a detector. We turn the light on and we see how long it takes to get to the detector, and we can calculate the speed. So you can see in space the speed is basically 3.0 times 10 to the power of 8 meters per second, 300 million meters per second. Here it's actually in kilometers per second, but I'm just converting. You can see here that when we go into air, the speed's lower. When you go into water, the speed's even lower. When you go into glass, the speed's even lower. And when you go into diamond, the speed's even lower. So that would mean that basically diamond has a very high index of refraction compared to, let's say, air. But we'll see more details on that shortly. So just as a reminder, the index of refraction is a number that tells you how slow light travels in a substance compared to in space. So what that basically means is that the higher the n value of a medium, the slower light travels in that medium. And the lower the n value in a medium, the faster light travels in that medium. Now the lowest n value you can get is n is equal to 1. Because if you think about it, nothing is faster than the speed of light in space. So if you got something less than 1, like 0.5, you're saying that there's a substance where light travels faster in compared to space, which is not a possibility right now. So really the lowest index of refraction you can get is 1, and that's only when you're in space because that's the fastest light travels. Now, as a reminder, if you have an n is equal to 2, that would mean that light is 2 times slower in that substance compared to in space. So the higher that index of refraction, the slower that light travels. And so what we're going to do in the next few slides is we're going to do some practice problems to try to solve for some of these variables given some of these pieces of information. We'll try something more conceptual first. So here's example 1. In which medium is light faster? One with n is equal to 2 or one with n is equal to 3.2? Explain. So I want you to pause the video, try this question, and then we'll check our answers. So if you did your work, you would have chosen that light travels faster in n is equal to 2. And that's because n is equal to 2 is a lower index of refraction than n is equal to 3.2. The lower the index of refraction, the faster light travels. So another way to think of it is, this means in this substance, light travels 2 times slower compared to space. In this substance, light travels 3.2 times slower compared to space. So this is slower and this is faster. All right, so now we're going to try a calculation style question. Let's move this over here. We're going to activate the pen here. So light travels in ethanol, which is a type of alcohol, at 2.21 times 10 to the power of 8 meters per second. Calculate the index of refraction. So you know that the index of refraction is n is equal to c over v. And you have some information given to you. You have that the speed of light in ethanol, so that would be v, is equal to 2.21 times 10 to the power of 8 meters per second. And you also have something not told you here, but you should know it now, is the speed of light in space, which is c, 3 times 10 to the power of 8 meters per second. So now that you have all that information, you can go and plug it into your formula. N is equal to 3.0 times 10 to the power of 8 meters per second over 2.21 times 10 to the power of 8 meters per second. And so you would plug this into your calculator, and if you don't remember how to use your calculator, you should practice with that to see how to put exponents on your numbers. But essentially, this is divided by the same thing, so that cancels out and the units cancel out. And in the end, you get, plugging it to your calculator, you should get 3 divided by 2.21, about 1.36. Now, this is the index of refraction. There's no units to it. All this means is that in ethanol, light travels 1.36 times slower compared to in space. Now, I know this is the right answer because if I go to my little index of refraction table here, ethanol, which is ethyl alcohol, is listed as 1.36. So what's cool is that each substance has its own index of refraction, and you can actually figure out what a substance is depending on the index of refraction that you've calculated for it. And you can do experiments to figure that out. So we can try this practice problem here. You can try it yourself first, pause the video, then try it yourself, and then check your work. The index of refraction for quartz is 1.46. Calculate the speed of light in quartz. So let's just write out some given information. First, we know the index of refraction for quartz is 1.46. And we also know that the speed of light in space is always 3.0 times 10 to the power of 8 meters per second. We're asked to find the speed of light in the substance other than space, which is V, for quartz. So we know that our formula is N is equal to C over V. Now we can't solve for V this way, so we have to isolate for V. We're basically trying to find V, which is our variable, so we can send this up here, and that would give us Vn is equal to C. We can then send n down here. I'm just isolating variables, so make sure you review that skill. So we get V is equal to C over n. So this is our second formula. We have n is equal to C over V, and V is equal to C over n. So C is always on top, and it's always a division. So now that we have that, we can plug our numbers in. V is equal to 3.0 times 10 to the power of 8 meters per second, divided by that 1.46. And if you plug that in properly, you'll get a long decimal, or a big number. And so I'll do 3 times 10 to the power of 8 divided by 1.46. And when I plug that into my calculator, I get 205,479,452.1. That's a point there, 1. And then the unit is meters per second, because the speed is going to be in meters per second. The index of refraction has no unit, but the speed does. Now, you could write this in scientific notation, and you can refresh your memory by going back to some notes in the tutorial. But essentially, you want to bring the decimal from here to between the first digit and the second. And you have to count how many spaces that is. So we're going to leave it to, we're going to round it to 2 decimal places. So it's going to be 2.05, because there's a 4 here, so you round down. And we'll count how many spaces we have to move. So 1, 2, 3, 4, 5, 6, 7, 8. Times 10 to the power of the number of spaces we move to the left, 8 meters per second. In this unit, your speeds are usually going to be times 10 to the power of 8. So some number times 10 to the power of 8. Because we're not going to slow down that much, and we're not going to speed up that much. So this would be your speed in quartz. And again, it's in meters per second. Now we can try this example out over here, example 4. So you can pause the video, try it yourself, and then check your work. So hopefully you've tried it yourself at this point. Let's double check our work here. So what is the speed of light in zircon, which has an index of refraction of 1.2? So use the index of refraction table. So in some questions that won't give you the index of refraction, you'll have to know to come to this table, and you would always be given this table. And so zircon is 1.92. So we want to know the speed of light in zircon. So we know that we have C is equal to 3.0 times 10 to the power of 8 meters per second. We know that the index of refraction from our table is 1.92, and we're looking for V. We know from our previous slide that V is equal to C over N. So that means we're going to plug in our numbers. V is equal to 3.0 times 10 to the power of 8 meters per second divided by that 1.92. And essentially we're going to have, if you just do 3 divided by 1.92, you'll get 1.56. And then it's a speed, so times 10 to the power of 8 meters per second. Because our speed of light is always going to have that base speed here, but a little bit less than 3 if it's not in space. And so that's the speed of light in zircon. Try this problem out here, and then check your work when you're done. by watching this video. So here we go, we're going to take this up. The speed of light in a glass sample is 1.82 times 10 to the 8 meters per second. What is its refractive index, and what type of glass is it? So the first question, there's two parts to this question. There's firstly, find the refractive index. So N is equal to C over V. And then the second part of the question is to tell us what type of glass it is. But let's just start with the first part first. So what do we have? Well, we have V. The speed of light in that glass is 1.82 times 10 to the power of 8 meters per second. We also have C, which is the speed of light in space, 3.0 times 10 to the power of 8 meters per second. And we want to find N. So we can go ahead and plug our numbers in. So N is equal to 3.0 times 10 to the power of 8 meters per second divided by 1.82 times 10 to the power of 8 meters per second. This cancels out top and bottom. So we're basically just doing 3 divided by 1.82. And we get 1.648. I noticed a lot of students forgot how to round. 1.648 does not round to 1.64. If you want to round it to 2 decimal places, we're going to look at the 6.4 here. That's 2 decimal places. You look next door, this is above 5. So this is going to round up. So this is closer to 1.65 than it is to 1.64. So this will be about 1.65. So that's the first part of the question. That's the index of refraction. The fourth part is we have to tell us the type of glass. So there's several types of glass here. There's crown and there's flint. So if you look carefully, the one that has the index of refraction that matches, our index of refraction matches the glass, that's actually flint. So the glass is flint, and we know that because it has an index of refraction equal to 1.65. And you can see that from the table there. So we just identified a substance using the speed of light for light in that substance. So in the next video that you're going to watch, you're going to learn about refraction terminology and learn how to draw refracted rays with estimated angles of refraction. In this video, we saw what it means to refract. We saw the speed of light. We saw the speed of light in space and the index of refraction and what that means in terms of the speed of light in different substances.